All right, so we're doing in cylinder now, and I don't need channel B for now. So I'm turning channel B off. Channel A, we have to tell it what probe we're using, which is our WPS 500 in the range 1, so the scales are set up for us already. We don't have to do math. This just changed this is still a frozen picture. Hit that live. Let's turn our zoom off. We don't want to have a trigger. Remember, when we're taking signals, we have no trigger or auto because we don't even know where we're going to be yet. This is going to be cranking. Again, let's do a cranking of the number 4 first, and then we'll do an idle. And I don't see a reason to do snap throttle and all this other stuff. We have an idle misfire. If we can't see it at idle, what's the point of holding it at a higher RPM? I don't know. I just don't see it. So let's do a cranking when I have all the coils unplugged. And Lenny, if you could crank that. I still want you to hold the throttle all the way open because I just want to make sure we're getting good flow into the engine and that we have the same conditions. Number 5 plug is back in, correct?
Yes.
Okay. So we can do a clear flood crank to keep it from starting, but just you know, kind of a double test here. We have all the coils unplugged too. Hold on one second. Why don't I see my there's my 0 line. As far as time frame, remember the Pico, you can take longer time frames and zoom in and still have really good detail. So maybe a 2-second screen might be pretty decent for a crank. So go ahead and do it, Lenny. Okay. And what we'll do is just kind of come back and look at those for a second. One of the things I didn't like what we were doing before is how deep that expansion pocket was. Remember us talking about pressure and vacuum, and if you look at this one, it's actually a little bit less pronounced. Let me zoom back out. Put a cursor on the 0 line. I just want to show you guys this pocket as best I can. Let's just do a cursor difference from here to here. Go kind of in the middle. That would be a delta pressure of 3.6 psi, which would be double that. So what's 3.6 times 2? 7.2. So 7.2 inches of vacuum on that expansion pocket. And there's stuff that is involved with that. I'm just pointing that one out. That looks a little bit different to me from what we were seeing before. Our peak compression, and it's pretty consistent. It's 152, roughly 152 psi. Here, we'll save this picture. This is number 4 cranking. Okay. And then plug those front 3 coils back in, please. And what we're doing, again, you guys remember, we want a 2-cylinder misfire. We're doing that intentionally so our running numbers are the same. And this will now be running. Go ahead and all of our cables clear, the belts and everything. All right, go ahead and start that, Lenny. We'll let the RPM stabilize as best as it will with a 2-cylinder miss. Trying to get the run time the same. All right, we'll go with that. Shut it off. And while I'm saving this one, if you guys want to swap this stuff, put number 4 spark plug back in, put the stuff in number 5. Wait, you know what? Before you do that, just a couple of views here. initially is the theory behind this, and this looks different from what we saw before, but the theory behind this is the expansion pocket and the intake pocket should be the same. Do you remember how sloped they look on the other scope we were using? And that makes me think it was the scope. I mean, look how even that looks. Remember, it was slanted?
Yeah.
And you know, I'm not sure exactly why they should always be the same. I mean, it has to do with cylinder sealing and intake vacuum. And by the way, that's 8.3 psi negative, so that would be roughly 16.6 inches of mercury. But remember, we have two-cylinder misfire right now, so we don't want to overanalyze. Wait, your vacuum's low. Yeah, my vacuum's low because we're idling with a two-cylinder misfire, and the throttle plate is open a lot more to maintain that same idle speed that would be there if those other two cylinders were firing. That's why the vacuum's lower, so we don't want to overanalyze that. I'll save that waveform, and we'll be able to do. Oh, wait, before I save this, I was just thinking about my overlays here. We need to run this again. Here's why. The reason we need to take this one again and set a trigger is when I do the trigger between channels, what I've found, and you know, someone from Pico can correct me if I'm wrong, but what I've found is if you trigger in the same place, it makes for waveform viewing of the two files so much better because you can pull them right over top of each other. Where if I'm triggering at the same time as opposed to not triggering, that's why I want to trigger. So start that back up one more time. In fact, we're going to redo the cranking one for that reason. And really, we don't need this much. I'm going to zoom in a little bit more. And as far as scales go, we can drop this a little bit. All right, remember when we do number 5 that we have about 6 waveforms on the screen? All right, good, kill it. I'm gonna save this when you guys wanna swap that stuff. Wait, I said I wanted to redo the cranking, I'm sorry.
Back on?
Put it back on. And the reason I wanna redo the cranking, instead of pulling, we're gonna pull some overlays in on this, but to have the triggers set in the same place is going to allow me to duplicate these waveforms and really just look at them both together. Okay, we're gonna redoing our cranking, and I'm leaving my trigger where it's at, guys. We should have no problem hitting that point. And go ahead and crank it. All right, hold on. Just want to increase my time base here just a little bit, get a couple more waveforms on the screen. Go ahead and crank it. All right, good. Do you guys remember remember I was on 100 millisecond per division for my running and 200 for my cranking. And this is, wow, that compression came up. We're at 168 now. And your pedal was on the floor? Okay, just making sure those variables. This is number 4. Okay, so let's move it to move everything to number 5 now. Remind me to change my time base on when we go to running to 100 milliseconds. We want to use the same time base for our comparisons. You guys see this little blip in this waveform right here? Let me zoom in on it while they're switching. Right here. That's that should be the intake valve opening.
Now, should it be just a straight line?
I don't know. I don't ever remember seeing that in a cranking waveform before. Are we good? I don't ever remember seeing one that was that pronounced. We're going to do cranking, then running. And we'll put, once we get these pictures, we can put our overlays in and talk about it. The degree cursors and stuff. We good? So we're going to do, this is our...
Do you want to take all the things off?
The coils?
Yes.
No, just go clear flow. Turn the key on first.
Key on.
Key on first, because if you don't do it in this sequence, it'll start. We're just going to do a clear flood crank instead of unplugging the coils. I mean, if it starts, shut it off. Oh, they are? All right. Pedal to the floor, and we're using the same trigger point, same time base. Go ahead and crank it. All right, that works. Significantly higher, it looks like, compression. We had, what, 160 something?
Yeah.
So we're at like 190 almost. Not as pronounced of a pocket in there, huh? All right, let's save this one. This is our number 5 cranking, right? And plug your coils back in. We'll get a running one now. And our time base was here. You know what's cool about this? Watch. Go File, Open, and then when we open the number 4 at idle, all the settings will be there. And then we can just hit the space bar and start it from there with all the same settings. And, or hit the space bar or just hit the green go and go ahead and start it.
Ready?
Yeah. And if you remember, we had the RPM down to a point where we were looking at 6 compression events. So we'll let the idle stabilize first. Because we really want the RPM to be the same. If you're going to compare idle compression readings, you want your RPM to be the same. Because you see the compression numbers coming down. What do you think? About there? Good? All right, kill it. File. Save that. All right, so now with the number 5 open, if we do a tools, reference waveforms for channel A, press duplicate, and that would be for that channel. It's okay. It's saved that. Now what we can do is we open up. This was the number 5. We just did that, right?
Yep.
So we open up number 4 at idle. This is the number 4 at idle, and then we can do a view. Tools, reference waveforms, and turn on number 5. And what's cool about now our RPM's off a little bit, as you can see, but the one waveform where the trigger is, see how we're like what we can do with that is we can really kind of make use of that. Although, here's the thing, as I'm looking at all of this, if our RPM is not identical, you can see how it starts to shift more and more and more. So one of the things that we would not want to do is look at this part and say, hey, let me move this. Look at the intake valves. They're closing at different times. So there's your valve problem. No, your RPM's different. And if we could get this at the identical RPM, I bet you we can't see anything with a valve issue in this waveform.
There really wouldn't be a valve issue.
Well, I mean, other than the peak compression, being different. Let's see. Can I do this live? We're in the number 5 still, right?
Yeah.
I wonder if I can. But that's the number 4 captured. All right. So I need to do that. I'm going to try something here. I don't know if this will work. Let's get rid of this waveform. I'm in the number 4. We're still in the number 5, right?
Yes, sir.
So what I want to do is I want to make a reference waveform for the number 4, which is that one. And what we could do is we can overlay that with the live number 5. And there's other ways to do this. We can pull cursors in, but I just think this might be cool to do. Okay, let's recapture the number 5. Go ahead and start it. I can. I just pulled the reference waveform in. That's this one. I learn some new stuff with this thing every time I use it. All right, I froze it right there. That's kill it. That's about as good. That's about as good as it gets, right?
Just a hair past it.
Dude, that is really cool. But here's the thing. That's really cool, but do I see a valve problem in this number 4 compared to the number 5? We can pull in the scope, overlays, and cursors all we want, and we can analyze it until we're blue in the face. Thank you. I don't think we need to with this reference waveform. I'm just excited that I could do that.
That's pretty cool.
You guys, you realize, what we did. I pulled the number 4 in as a reference, and then we're measuring the number 5 live over top of it. All right, now, is there something in there that I don't know? Now, I would need more training on looking at this area in here. Wait, let me save this before I lose it. So now we go in and we look at some areas in here, and there's a lot of detail. Some of the things that we would look for would be during the oscillations, like in this area here. What I've learned about this area here is they'll look a lot different depending on where the cylinder is in the exhaust manifold, because this is really the exhaust stroke. These oscillations in here is when the exhaust valve's open. So those oscillations would be other cylinders that are feeding into that manifold. And if you're looking at number 4 compared to number 5 is on the end, number 4 is in the middle, and you get more pressure impulses from other cylinders on the number 4 than you do on the number 5. That's one thing that we can have. So I wouldn't look at that area and say, hey, I got a problem. I'm sure there is someone out there who could be like, there's your problem there, look at it. But if it's me, now think about this at face value. We know what about this car? We know we have a valve problem. We know we have an intake valve sealing problem. You guys agree? All right. Are you going to pick out, so here's the number 5 in the darker blue. The number 5 in the darker blue that does not have a misfire. And the number 4 in the light blue that does have a misfire. Are you going to pick that out and say, by this waveform, that you have a valve problem? I don't think so. I'm just not that good with these waveforms yet. So, we really had the same thing with the Varus. If you think about it, the patterns were pretty much identical. They weren't as clean as this. I think you see the power of the WPS 500 transducer here with the Pico. Questions? Anything else we need to revisit? Intake vacuum, one more time. This needle was nice and steady. Map sensor, we analyzed the crap out of that map sensor. We couldn't see anything there either. I mean, nothing definitive that I could see. There's some sensors you can put in the intake. Let's say if you don't have a map sensor, it's called a first look sensor, something that you guys may want to look into. It's basically a pressure transducer that makes a signal just like a map sensor would. Now, I want one because you can put it in the exhaust, you can put it in the intake and read pressure pulses with it. It's called a first look sensor.
First look.
First look, yeah. Yeah, the leak down, again, TDC, bottom dead center, valves are closed. We had leakage in number 4, bad. And fuel trims look normal.
So that number 4 is the only one that they have to replace?
No, you're gonna pull that head off and do valves. You're doing them all.
Okay. But your 4 is your problem.
Number 4 is the problem. The only thing we see in this waveform, this compression waveform, is just a little bit lower peaks.
Right.
That's it. And maybe to make that a little bit more, you know what, we won't zoom on that one. Let's make that a little more pronounced with the two that are kind of next to each other, these two. You know, that's the only thing you see is the number 4 is a little bit lower compression than the number 5 is. Number 5, this is running at 101. This is running at 90. The only other thing we didn't do, I guess, is the cranking comparisons side by side. So let's open number 5 cranking, and let's do a reference waveform of that. Remember that's A3. Let's open up the number 4 cranking. Pretty close in RPM. Go tools, reference waveforms. Oh, I forgot to save it. Darn it. Okay, let's do that again. This is number 4. Tools. Let's make a waveform of this. Duplicate. And press OK. I don't know if I did that or not. And then let's open up number 5. And pull in our number 4 reference, which is that one. And there's the 2 cranking. And you can see our RPM's off a little bit, but cranking on our number 5 were about 190, and then the number 4, the reference, is 167. That's all we see. If you were to zoom in on that area, remember I was talking about that little blip in the screen, that little area right there? Well, yeah, there it is on the number 5 too. All right, but ultimately with this car, what is it? It's not fuel trim. It wasn't the vacuum gauge. It wasn't... What else did we check? What all did we check? Actually,
Compression cylinder.
we
compressions.
started this job knowing that we potentially had a mechanical problem going into it. And so we were focused on mechanical from the get-go. We started with a relative compression test, and we did see the number 4 was lower than the rest. So we immediately started going after mechanical issues. The vacuum gauge didn't show it. I don't think the in-cylinder pressure sensor shows it. I mean, we see a little bit less compression, but we saw that at the battery during the cranking test. Our leak down is the test that showed it to us. Of all the stuff, fuel trims look normal, O2s look normal. Granted, we do have an exhaust manifold leak here too, which can throw that off a little bit, but I didn't see anything on the scan tool that would have helped us. Other than, showing a misfire and maybe normal fuel trim numbers, where typically ignition or a injector misfire, you see more positive numbers, so that may be worth discussing, but that's, again, I don't know. It was really all boiled down to a simple mechanical 5-minute test. If you think about it, it would have been relative compression test, low compression on the number 4. We identified that very easily, and then putting that leak down tester in the number 4, you would have been done. This would have been a 10-minute, 15-minute diagnosis. Oh, and the map sensor too. That didn't show us really anything, and we analyzed the crap out of that, like I said. So, simple test is sometimes better than complicated. But I think all of the stuff that we did was valuable. Scoping a map, scoping the cylinders, all of it. So thanks for helping me out, guys. I really appreciate that.